Something you said really struck with me, that you are producing diamonds and Coca-Cola out of thin air. Am I right to say this?
We are the company who get the CO2 out of the air, and then we have a lot of partners who can do everything they want. So what we aim to be is like an enabler, right? Because if we get CO2 very cost efficient out of the air, you can do basically anything with that.
I've heard about DAC systems that are able to capture carbon out of thin air. Something about Ucaneo is unique, which is not being done by others. So can you tell me a little bit about that?
So normally how direct air capture works is that you're binding CO2 to like a chemical sponge, basically. When you bind it very, very strongly, it's atomeric covalent bonds. You need a lot of heat to always bind, and that's why it's very, very energy intensive. And what we do is we basically develop a new technology, which is an electrochemical approach, mimicking the way how humans are breathing. In your lung, you have little molecular machines which help you, for example, like to breathe or to breathe out. And we either mimicking those by, for example, polymers or like in general salts. Putting this in solvents, you can do everything under room temperature. You only need electricity, and it's a very, very clean and yeah, very promising approach.
Hello, Florian. Thanks for joining me on Scouted by GreyB. How are you doing today?
Very good. Thank you so much for having me here today. Yeah, very excited.
That's nice. So before I jump right in, I wanted to ask, Florian, anything new or exciting recently happened in Ucaneo that nobody knows yet, but you'd like to share it with me first?
No, definitely. I mean, some exciting parts. We just announced it actually 2 weeks ago. So many people know already, but still, we got Saudi Aramco as a new investor, which we're very, very proud of. Because we're developing a new technology, right, to remove CO2 from ambient air. Very excited to have strong new partners on board.
That's nice. Congratulations. And thank you for sharing it with me. Can you explain what Ucaneo is doing? What are you guys making, and how is it impacting the world?
Yeah, I meant to say it's super simple, right? So, I mean, everyone knows climate change is here. And the problem is we already emitted so much CO2 that it's not enough anymore to just reduce the emissions. So to reach our climate targets, there's this big chunk we always have to reduce, but then there's always something left, which is coming from very hard to abate sectors. So for example, if you think about flying, very, very difficult to get it to carbon neutral. So what we're developing is basically a machine which removes CO2 from ambient air. So you can imagine like 35,000 trees on 15 square meters. So it's a lot of CO2, which we remove from the air. To say very simple, it's basically a machine, air is coming in, and we filter the CO2 out, clean air goes back into the atmosphere. And the CO2 which you filtered out, you can use that to either produce any kind of products from like your Coca-Cola on your desk. You can use that CO2 from like agricultural farms, but also even making like diamonds out of it, or synthetic fuels for carbon neutral flying. Or you're storing the CO2 very long term to issue, for example, carbon credits. And these carbon credits is basically when a large organization, for example, Microsoft, has net zero targets by 2030, they can use these emissions or these certificates to offset their own emissions.
That's great. And something you said really struck with me, that you are producing diamonds and Coca-Cola out of thin air. Am I right to say this?
Yeah, exactly. So, I mean, we are the company who get the CO2 out of the air, and then we have a lot of partners, downstream partners who can do everything they want. So it's a little bit, imagine like building a whole new oil and gas industry or sector. Yeah, basically this very sustainable product of the future, and this is what we try to do. So what we aim to be is like an enabler, right? Because if we get CO2 very cost efficient out of the air, you can do basically anything with that.
Yeah, and actually, I've heard about DAC systems that are able to capture carbon out of thin air, and I don't know why I said thin air, but so yeah, there is a system existing. They have been a lot of research on this area, but something about Ucaneo is unique, which is not being done by others. So can you tell me a little bit about that? I know about it, but basically for our audience.
No, it's a very good question. So normally how direct air capture works is that you're binding CO2 to like a chemical sponge, basically. When you bind it very, very strongly, it's atomeric covalent bonds. You need a lot of heat to always bind, like break it up again. Binding, breaking up. And that's why it's very, very energy intensive and very, very, expensive. And what we do is we basically develop a new technology, which is an electrochemical approach, mimicking the way how humans are breathing. It's just like very, very exciting. It also is. So you can imagine in your lung, you have little molecular machines which help you, for example, like to breathe or to breathe out. So they accelerate this process of CO2 getting into liquid or getting out of the liquid again. And we're basically using these biomolecular machines, and we either mimicking those by, for example, polymers or like in general salts, putting this in solvents, and together with an electrochemical approach, have a technology in the end which is not only much cheaper, but especially this comes from being much more energy efficient. You don't need, for example, high temperatures of up to 900 degrees. You can do everything under room temperature. You only need electricity, and it's a very, very clean and yeah, very promising approach.
It sounds very promising. You mentioned it's you can basically all it needs is electricity. Uh, so basically, when I say all it needs is electricity, is it really true? That's all you need, because a lot of other system they use chemicals which bind the carbon dioxide, which needs to be sometimes replaced, or which sometimes they are spent and then they need to be refilled, or they need extra processes to clean up again. So is that not the case in here?
Yeah, no, it's a good question. I mean, in the end, there's no system existing which doesn't need replacing, right? You're building these machines which should be out there 20 to 30 years. And of course, every few years you have to replace parts, right? This is otherwise this doesn't exist. Yeah. What makes it unique in the end, this system, yeah, is we have a liquid electrochemical approach, and you can basically co-locate it very, very well for renewable electricity, like wind or solar. So you can very easily say, I switch it up or I switch it down, basically, or switch on, switch off. And this helps you to really reach very, very good cost targets. But from the components it uses, the most expensive one is the electrochemical cell. But we're already taking them from other industrial applications where they have like many, many years of lifetime. And then you always still have to replace those. But from the liquids to solvents, we have a mainly water-based solvent, and it's very easy to replace it. It's not our main cost driver. In other DAC applications, that's the most expensive. They also don't last that long.
That's great and really interesting to know this. About DAC system as well, there was one thing I was curious when I was doing research, and it's a great analogy you provided, at 35,000 trees in just a very small space. So basically a forest in a very small space, right? So apart from this, I'm sure you have run a lot of pilot programs already, which proves that this, it has the potential to really revolutionize carbon capture. So can you share some more numbers with me? What kind of feedback have you received from your clients, or what kind of impact so far basically Ucaneo has been able to make it?
Yeah, no, it's a very good question. I mean, last year we raised a 7.75 million seed round, right? And what enabled us to raise that round was actually we had a very small lab prototype, and we did a feasibility study with a third, with an external party, because everyone always tells you I'm going to be below 100 euros per ton, right? But it doesn't help me much, because is it going to be in 10, 15 years? At which scale is it going to be? And out of this feasibility study, we could already show with the efficiencies we already showed in the lab, plus the parts which are out there you can buy, we can already reach cost of below 300 euros per ton. And this already in the upcoming years. And this would make it to one of the cheapest technologies in the world. And that's very, very promising. And since then, we actually scaled up our technology already to 30 up to 50 tons capacity per year. And that's already one of the largest, from our knowledge, the second largest pilot in Germany. And this we're currently in the process of commissioning it and generating the data to show really this works also on industrial scale, and we get the same efficiencies. What happens next in our plan is actually then to really, really build large plants, but that's happening next year. So we have a lot of confidence. We know it works. And now we're in this process of proving how good it actually works, because in the end, this is, of course, an efficiency game.
Yeah, you're right. It's all about efficiency. And thank you for mentioning the target of cost that you're aiming. And 300 euros is definitely very cheaper than compared to others, because what I know is, I think on industry on average it takes around $600 to $1,000 to remove 1 ton. But then there are some companies, some recently coming up companies which are also promising similar numbers, right? For example, I found one, and again, I think this question is a little critical, but I'd still like to ask. You must have heard about Heirloom. It's a new startup coming out of USA, right? So they are also promising something around $100 per ton capture cost, right? So, and I'm sure, being your competitor in a different geography, not even different geography, actually, carbon problem is global, right? So can you share something, maybe a little comparison, or if just your comments about it?
That's a good question. I mean, in total, today, right, there are roughly 120 to 140 companies working on different DAC technologies, and 80 or a little bit more just working on this very traditional approach, which is basically a heat-based driven mechanism, right? So there's always this binding and release mechanism, and normally it's driven by heat. In our process, it's electrochemical driven by pH. And as mentioned, everyone basically claims or says we're going to be below 100 euros, right? We also, of course, when we do the calculations and get all the best efficiencies in we can achieve, we can reach roughly like 70 euros per ton, for example. But why we did this feasibility study, because it doesn't really help anyone if you always claim I'm going to be at 50, 70 euros per ton, but actually today I'm at 700 to 1000. I think it sometimes sets wrong expectations. So there are several dynamics in it. I know there are also some cost targets of companies having like 300 and below by 2030. And maybe 150 to 200 euros by 2035 or 2040. So I think it's also good to make it a bit more realistic where we're going towards to. But I know every DAC company, and you just mentioned Heirloom, for example, Shashank, he's an amazing founder. And of course, everyone knows each other basically in the industry. They're a very great company. And I also hope they're really going to succeed, because the more DAC companies succeeding and getting better costs, so the better the market is forming, and the industry is coming together. We're all in this together. The amount of CO2 we have to remove from the air is just very, very high. Long term, we also have cost targets of 50 to 100 euros, but as mentioned, in the midterm and short term, below 300. And this is something we think is a bit more realistic.
Yes, yes. And it's totally understandable. Things cost and scalability improves as we go ahead, and as basically technology improves and you get more partners and more logistical support.
And something which is very important to mention, you always make estimates how long, for example, some of your key components last, right? But you only know how well the system performs as soon as it's out there in the field and it's really performing. So if instead of saying, okay, this thing lasts 3 to 5 years, put it first out and make it last 3 to 5 years, right? So that's why we're always a little bit hesitant. We really want to prove it. Climeworks, for example, is a great company, and they've been working on this for many, many years, carbon engineering as well. And the costs are still very high. So this is a challenge which is not easy, right? But of course, everyone is giving their best.
Yes, yes, definitely. So now let's also, all my tech questions are answered. So I also wanted to explore a little about logisticals and scalability of, Ucaneo systems. So I understand that basically this device is modular, and it can be basically, you can stack as many of them to have a bigger impact. But yeah, I'd like to know basically how easy it is for, let's say, a company like Microsoft or any other big company to adopt Ucaneo's tech and implement into their own already ongoing operations where they want to save some carbon. So can you shed some light on that?
Yeah, it's a good question. So, there are different ways how to work with us, right? One of the easiest is I'm going to say, hey, I want to offset my emissions. I'm basically just buying carbon credits from Ucaneo. And that is very, very simple. You let us know how many tons you want to get removed. We're building the plant. We take care of everything, storage, MRV, and you get the carbon credits delivered, and that's it. That's probably the most simple way of engaging. And this is normally what, at least from our understanding, Microsoft, for example, is looking to. Then the next more degree of working together can be, we know some customers who say, hey, this is a very strategic asset for me. It's very similar, for example, to renewable energy. There are some companies who say, hey, you can either, for example, do a power purchase agreement, or they actually say, hey, I want to own, for example, a solar that I can have full control about the electricity. So we saw companies that can be similar way. We're creating an SPV model for a certain plant, and the company says, hey, I want to own 10, 20, 30% of that plant, and then reflecting also getting these carbon credits. That's also another way. Or if you say, hey, I want to be, when we especially talking about large energy, oil and gas companies who really want to operate their own plants, what they can do is also created in SPV models. Basically, they can license our technology or co-deploy the technology together with us, because that's always about scale, right? And scalability in the end, what we do is a very capex and capex intensive product we built. And of course, a very large organization like Saudi Aramco have very, very different capital costs than a startup of 20 people. So, and they're also very interested. They have a lot of expertise. They have a lot of land. So our strategy is to really, for us, what is the most important is impact means scale. So we want to scale it with these large partners. That's normally the 3 ways how to work with us. And because you also just mentioned about the modularity, what we build is actually not, I know on our website you still see sometimes these containers, but we're not building containers. That's basically you always start with a container to somehow start with something, but normally you can imagine it's a big industrial hall and then you have fans outside. So it looks much more like a desalination plant, for example. And our technology is still quite modular because it's with electrochemical cells. And these you can basically stack up, which is very, very nice. And the aeration, for example, scales with size. When you look at carbon engineering, it's very, very large fans. And for us, it's very similar. But electrochemical cells, you're just stacking those up. So from the way how we engage with customers, we think we have a very good way how to scale it. But also from the technical stack, there's a quite nice way how to scale it up. Just because of this electrochemical approach allows us to be much, much more modular than, for example, other technologies.
I think all of this together, like being the modularity and being so easy to work with, that companies can directly buy carbon credits from you. And carbon credit is something I think a lot big companies, they prefer that way because it's much simpler for their operations, and it's very simpler. It's very quick for them as well.
It depends on the organization, because sometimes this is a topic you should always talk about. Companies are afraid of, for example, greenwashing, which is also absolutely correct, right? Because sometimes I was asked, hey, there's this big scandal about carbon credits and planting trees and so on. What do you think about it? Or is it affecting you in any way? And actually for us, it affects us in a really good way, because you then want to make sure you want to have a very, very robust way to remove CO2, a way which you can measure very easily. For us, we have this big advantage in the end. Basically, there's a pipe, CO2 is coming out, which you got out of the air. So you can measure very easily how much CO2 you got out. When you have more nature-based approaches, these tend to be much cheaper. There's already significant scale, which is great, but it tends to be a bit more difficult to measure. So what we also see from the customers, there's no best solution or wrong solution. It should always be a portfolio approach of different solutions you can get. But for us, it's definitely one of the most robust ways and scientifically robust ways, but then also comes with a cost. So it should be always in a portfolio approach, meaning that, as mentioned, some of the customers tend to get portfolios, and some other companies tend to actually invest and co-own some of the assets to then also have control, because it means they can always go to the plant, look what's happening. They get all the information, which is not maybe publicly shared all the time. So there's also a lot of interest for some customers to actually co-own part of the plants.
Okay. This is, I think the transparency part is really nice, that you can simply just go walk to the plant and measure how much carbon you have saved, which it adds to the simplicity of the whole system.
Exactly.
So again, I think you mentioned, and now that we are talking about greenwashing and carbon credits as well, there are a lot, sometimes there are a lot of criticism again regarding greenwashing as well. And sometimes it's like a lot of companies lies about their how much carbon they're actually, even in case of credits as well, how much they actually are saving and how much they are reporting outside. So are there any kind of regulation or guidelines that Ucaneo follows, or you make your customers follow?
Yes. So how I see it is, I mean, it's now a surprise. First, you always have to start measuring, right? So you always start with seeing what's actually my CO2 footprint and trying to identify where it's coming from. It's always the first step. And I can always recommend to go at, like, basically, for example, the science-based target initiative. Start with initiatives like that, where you have like a way where you can really measure and report what actually your CO2 emissions are. And from that, you can make a strategy what to do. The first step is always reduce your own emissions. So every company or customer we're talking to, and they're like, hey, Florian, I really want to reduce my emissions. Can I buy you carbon credits? I always recommend them first, always reduce your emissions. It's cheaper, it's better for the environment. Always start with that. And the cherry on top, if you say net zero, this is very often, at least I have the impression, not everyone understands. When you say I have a net zero target, it doesn't mean that you can only reduce. You always have to buy negative CO2 emissions. So that means CDR, like carbon dioxide removal credits. And then this is the time where we coming in, that you can basically buy these certificates. And for other companies, there's different motivations behind it, right? Because you asked me about regulation, etc. This is all the voluntary carbon market, right? And voluntarily means it's voluntary. So you can decide if you want to do it or not. And when I think about regulations, one of the best ways, you can see that in Japan, for example, and there's also some discussions in Europe. to bring this voluntary carbon market into the ETS market, so the mandatory carbon market. And the very important, the mandatory one, or the public carbon credit market, is you basically buying, when you buy a certificate there, it gives you the right to emit 1 ton of CO2. So basically to pollute. Yeah, it gives you the right to pollute. What we are doing is actually, we're a little bit like a chemical waste company, right? Or someone who picks up your trash, actually. So when you actually put all the trash in the air, we coming and bring it and getting 1 ton out of the air again to remove this trash. So we basically, you pay us to remove a ton. So there's a slight difference. And so from the regulation, I see there are a lot of interesting parts, but normally the companies which move the most, or what we see is really who set their net zero targets. And net zero target means even if they start reducing their emissions now, it means that by, for example, 2030 and so on, they have to buy a lot of carbon credits. But the question is, especially when we talk about this very high quality carbon credits like direct air capture, there's always a question, is there going to be enough capacity, right? Because the capacities today are very limited. There's not enough supply. And so we also have customers who start working with us today, investing in us today, buying carbon credits from us today, so that in order basically tomorrow there's enough capacity to fulfill their needs.
Right. And what you said about, it's extremely difficult. It's almost impossible to go completely carbon neutral. Basically, if you're just sitting and watching a video, you're still emitting some kind of carbon. So definitely, I think the end of the, you could say, last mile is you have to buy carbon credits. And I think it's going to be, and I think the interesting part is that the scalability of DAC systems compared to actually reducing carbon, because then companies will have to invest a lot more into changing their processes or maybe innovating new stuff, which again, sometimes it could be their expertise, sometimes it might not be their expertise.
I mean, in the end, it's all a question of cost and scalability, right? There's also the discussion of, for example, synthetic fuels for carbon neutral flying. Is it actually cheaper to just remove the CO2 and offset the emissions? Or is it cheaper to basically take the CO2 we get out of the air to make synthetic fuels to then fly, right? And there are many, many good arguments in both directions or opinions. But in the end, the question is just how much does it cost to remove CO2 from the air? How much does it cost to make synthetic fuels? So in the end, it is, as always, it's just about the price and the scalability.
Yeah, got it. So now I'd like to know a little bit about, the scaling strategy. And I'm not talking about the production, of course, but since we have a very unique technology on our hand compared to, what already existed in the market, and it has a good potential of, even the cost, the operation cost is going to be much cheaper, as you shared, that it's going to come down to even $70 or 70 euros per ton. So what kind of strategies are you employing currently to, maybe widespread this as much as you can? Because the competition is fierce and there are a lot of new companies coming up. Yeah.
I mean, the most important is to make already a decision in the beginning. What do you exactly innovate in, right? What is your core IP and what can I take already, which is maybe out there? When you develop a very hardware intense or really hardware product, one of the best things you can do is take a lot of components where already existing supply chains exist. So it means, for example, our electrochemical cells are already used in water desalination or in industrial processes recovering acid and base. A lot of the cooling, like the aeration parts we take, is taken from existing cooling tower companies or industrial supply chains. So a very big advantage what we have is taking a lot of parts from existing supply chains. And then, but if you would take all that and I don't know, you would say, Florian, tomorrow, I'm going to build this just myself. I just take all that and also put it together. It will not be cost and not energy efficient. So where the core IP is a lot about the process, how you design the process, how to make the key design, for example, of the cell or the large machines and the solvents you're using. There's a lot of knowledge and IP in there, but we can go to a supplier and tell them, please build it me ABC and already get it produced and delivered. So this is one of the main important things is take parts off the shelf. Yeah. The second most important is build modular. Always easier. Reduce your risk and you can basically start building a plant from 1,000 tons and modular basically increase that maybe to 10,000, 100,000 tons. So it's a lot about modularity and taking parts off the shelf. And that really helps you to scale. And the third part, this is what we're doing also today, is having very, very large and good partners who, for example, done it already or know how to scale. And that's why, for example, we also decided to work with Saudi Aramco. It's not only about the resources, the monetary resources they have. It's a lot about their expertise. These guys have been building industrial, very large plants, which is a scale you find only in oil and gas and chemical industry. You don't find it in any other industries.
Yeah.
And this expertise they've been handling CO2 for decades. So really finding very large partners with a lot of expertise who can really help you drive.
Makes sense. And you're right, actually, having good partnerships, it's good for both parties. And I think a lot of startups really leverage this, that the first partners, they act like their own, I would say, own leadership that helps them grow. So I'm imagining this is how it's working for you as well, partnering with Armanco. So Florian, I think that I'm at the end of the line of my questions, but I still have one thing that I, ask every founder. And this is something for my personal motivation. This is a crowded space, DAC, right? But coming up with a new solution, but it's also, there's so much market to capture. And like they say, you're eating an elephant one bite at a time. So, but again, it's no easy coming up with a new technology in a crowded space, which has like such a great potential to go. My question is, when working in, Kenyo, and basically you must face, every founder face this fear that maybe this is not going to work, or maybe this is like already crowded space, maybe it might fail, or these kind of thoughts. I'm sure you might also go through it. So how do you, like, basically what's your strategy to overcome these and just keep going?
No, it's a good question. I mean, first of all, of course, it's somehow a crowded space, but also not, right?
Yeah.
Because it's basically, we're not like AI chatbots, right? There are only like 120, 130 companies in the whole world. But the problem is you just need so many resources, so much money and talents and scale up. That's why sometimes people say it's crowded, because maybe there's not enough for all of them. But if you look at the challenge we have, like to reach our climate targets, we have to move up to 10 billion tons of CO2 every single year by 2050 from the air, right? And that's 25 times the weight of all humans on Earth combined. Every single year of the CO2 you have to move from the air, and there's only 0.04% of CO2 in the air. So you can imagine this challenge is crazy how big this challenge is. You, for example, the oil and gas industry moves 5 gigatons, so 5 billion tons every year. So it's you try to build up an industry which is double the size of oil and gas in less than 30 years. And this is sometimes when investors ask me, Flo, why do you do this? Why do you trying doing that? So what keeps me like sane basically yet, or keeps me motivated, is someone in the world has to try it. We are not doing this only for us, right? We do, like, if we succeed for everyone. It's very, very motivating. We have a very great team of people. They're very motivated, and for them it's always, Flo, imagine we're building this, it can change the world, and afterwards I can say I've built it. So if you have this thought, it makes you running, because of course being a founder, building something is just pain. And this pain will just continue to do, especially if you're hardware and you're waiting 9 months for a pump. Yeah, that's really painful. But I think this is the most important part, yeah, to stay motivated and actually know what impact your solution can have.
I think really believing in what you're doing is going to create impact, and then having a very good team to support you, and also it embarks kind of a responsibility you have to keep going. So I think that is what I got out of this conversation. So thank you for sharing this with me, Florian, and I really enjoyed our conversation. I got to learn a lot about this space. So thanks for taking me through this whole.
Perfect. Likewise, Shabazz, thank you so much again.